Okay, so I'm going to put this presentation up. We already covered this in class before they closed classes on campus, but I'm going to put this up to give everybody something to review and look at. This is the basics of the chapter. So for each chapter moving forward, I'll just put up a succinct presentation. I'm not going to put up 2-hour presentations. Everybody should really dig in deep into the textbook and read it because this class really sticks close to the book. I don't bring a lot of things in outside the book because this is enough for people to grasp and get through. So I went through this last time. I'm going to go through it again so you guys have something to look at. So this is from chapter 9, hypothesis sampling. And so I'm going to go over some of the basics. So what you're going to see in these slides moving forward, these presentations online, I'm going to put the meat and potatoes, the core things from each chapter on these slides. No fluff or anything. I'm just going to get right to it. So on this slide, what we're going to do is you should understand what hypotheses are, or hypothesis. Hypothesis is singular, one. Hypotheses is plural, more than one, 2, 3, or 4. Okay, so again, as we went over in class, this is going to be a recap. So again, a hypothesis, look, you don't test the theory, not directly. Theories are long, long explanations, like could be hundreds of pages. How do you explain something that's going on in society, like crime rates or any kind of behavior? It could take a long explanation. So what you do is you create a hypothesis that's derived from the theory. You actually test the hypothesis. You don't directly test the theory. You test the hypothesis and see if you find evidence to back that hypothesis up. If you do, then you've supported the theory. If you don't, then you fail to support the theory. And if a lot of studies are done that continue to fail to support the theory will fade away. So maybe the theory isn't accurate or it needs to be modified. So a hypothesis is a very, very short sentence. Usually it's one sentence. Sometimes it's not even a complete sentence. But it's a statement that shows relationships between variables. So you might say something like this: boys are more aggressive than girls. It's a very, very simple variable. You can go out and test it. You can see if little boys, maybe in elementary school, are more aggressive, and then you would define what aggressive behavior is, and you would go out and test it. Maybe you have a hypothesis that says something like students that graduate from Northridge on average make more money than students that graduate from Cal State Los Angeles. Then you would go out and you would test that through statistics. If you find evidence to back it up, you support the hypotheses and you thus support the theory. So that's what a hypothesis is. So that's what we test. And remember, it's very important that you remember, you don't just randomly decide if you supported the hypothesis. A lot of people make the mistake of going, here's some evidence, I supported the hypothesis. That's not how it works in statistics. In statistics, it's the numbers that determine whether or not you support the hypothesis. It's not whether you see something taking place or not. It's what the numbers tell you. Okay, so even if you believe you saw something, if the numbers don't tell you that anything real is there or significant is there, then you didn't support the hypothesis. Okay, so the null hypothesis, null means nothing. It means nothing's going on. So null hypothesis means there's no relationship. So that would say something like, you might say that boys are more aggressive than girls. That would be the alternative hypothesis. That would say that there is a difference. If you said boys and girls do not act differently when it comes to aggressive behavior, that's saying there's no differences. So that's the null hypothesis. Okay, so remember, the null hypothesis says that there's like no effect, meaning like yoga does not have an impact on anxiety. The alternative hypothesis would say yoga does have an impact on anxiety, meaning it's effective. So I mean, if you have people that have high anxiety and you treat them with yoga therapy, that their anxiety levels are going to go down. So typically what you're looking for in research is you're looking for effects or differences. So we want to say that yoga can help with anxiety. You see in there on the slide it says HO, that's just the symbol for the null, HA, or HA is the symbol for the alternative hypothesis, which is also called the research hypothesis. Okay, so the alternative hypothesis is the research hypothesis. You may sometimes see instead of saying H1, it may say like, or HA, it may say H1 or H2 or H3, because sometimes there's going to be more than one hypothesis in a study. Let's say there's 3 hypotheses in the study. You'll have H1 for the first one, H2 for the second one. So HA or H1, 2, that's alternative. HO is the null. Now, if the hypothesis makes a claim of direction, it's called a one-tail. That means it goes in one direction under the curve. If you say boys are more aggressive than girls, that's a directional statement. You're making a statement that boys are more aggressive than girls. That's going to go to the right. Like if you're looking at the bell curve, it'll go in the positive direction. Non-directional means that you're just saying that there's a difference here, but you're not stating what it is. So you might say people from different religious backgrounds graduate from college at different levels or different rates, but you're not stating what religion, you're not stating which religions graduate from college at higher rates than others. So it's a non-directional. So anytime you're just making a sort of a generic blanket statement about difference, but you're not stating what the difference is, it's non-directional. That means it can go in either direction under the curve, either to the left or to the right, meaning in the negative direction or the positive direction. That's a two-tailed. Okay, again, so if you say something like people who graduate from college make more money than people that don't, that's directional. If you just say people that graduate from college and people, you can make these statements any way you want. You can make them, I haven't gone into direction yet, but positive means the variables move in the same direction. Negative means they move in a opposite direction. It doesn't mean negative like a bad thing. It just means it goes in a different direction. So the more people work out, the less body fat they have. Okay, that's a clear negative relationship that's making a statement. The more you work out, the less body fat you're going to have. Okay, or something like this. So this is what hypotheses are all about. So you want to make sure that you kind of have an understanding of what the null means. Remember, the null means that there's no effect. That means nothing happened. And any differences that we see is just due to error in the study. It's not a real difference. It's just a difference. So remember, anytime we're sampling from a population, there's always going to be a difference between the sample and the population. Okay, because if there's 20,000 people in the population you're studying and you only sample 200 of them, what about those other 19,800 that you didn't study? There's going to be some error there. The question is that error real, or is it due to, or are those real differences? Okay, so what you're going to do when you're doing studies like this is you're either going to find evidence to back up the alternative, or you're going to fail to do that. So you're going to say, in your book, you're going to see the author says, we accept the null or we accept the alternative. Another way to say it that usually we say it is we fail to reject the null, okay, or we reject the null. So understand this, if you say you reject the null hypothesis, you're automatically saying you accept the alternative, because you can't accept them at the same time because they say the exact opposite thing. So if you say we found evidence to support the alternative hypothesis, by definition and by default, you're rejecting the null hypothesis. So keep that in mind. You can only accept one and reject the other one, but you want to be clear about what it is. Okay, now let's go into the idea of random sampling. People mix up this word random a lot. Like if you were walking through campus at Northridge and you just happen to ask whoever you ran into a few questions. Do you think they should raise tuition here to build a new building? A lot of students will say, well, that was random because I just ran into them. That's actually not what random sampling is. So make sure you understand what it means. Random sampling means that everybody in the population that you're studying has an equal chance of being selected to be in your study. Just walking down the hall in Sierra Hall and bumping into someone and asking them, that's not random at all. That's haphazard. Random means you know who they are. Like we know who all the students majoring in the disciplines are. We could build up a sampling frame of all their names, have a computer generate something. So let's say I want to randomly select 150 people majoring in this department. A computer will randomly select 150, and then we'll go to those 150 and have them put in the study. That's what random sampling is. And the reason you do random sampling is because you want your sample to be like the population. And we call that minimizing bias. Like if you're just walking in Sierra Hall and you see some friends or you see somebody that happens to be in the hall, that's going to be a biased sample. It means it's not going to really be that reflective of the larger population. So random sampling, remember guys, when we do research, like statistical research, we're never going to eliminate error. It's not going to happen because sampling always has some flaws. Your goal is to reduce the error. You want to make those differences as small as possible. So the best way to reduce error is random sampling. And the other way is to make sure that your sampling frame is right, meaning you're sampling from who you say you're sampling from. So if I'm talking about students at Northridge and I'm collecting data from students at Pepperdine, the sample's flawed no matter what I do. So you want to make sure there's 3 things you got to do. Make sure you're sampling from the right population. Random sampling is a good way to minimize error. And you also want to make sure that your sample size is big enough, because if you only select 5 people, there's still going to be big error there. So one of the best ways to reduce error is to bump that sample size up and make sure you're sampling from the right group. So you'll see on the slide it says small differences may be due to error. So anytime you compare, let's say maybe girls to boys, there's going to be differences there. But are those differences because of gender, or is it just because of the people you selected for your study? So there's always going to be error. Small differences don't give us a lot of confidence. What we like to see are large differences, because large differences tell us that it's probably not due to error. It's because these groups really are different, meaning college graduates really do make more money on average than people who don't go to college. Okay, that's what it means. And we want to have confidence when we make that statement. Now remember, we went over this in class, but just to recap it, a type 1 error is called an alpha error, and a type 2 error is known as a beta error. And the reason they call them this is because the type 1 error is based on where you set your alpha level. And again, I'll go into more detail on that in chapter 10, but just kind of keep that in mind. If you set your alpha level real high, meaning you give yourself a 25% chance of being wrong, you're going to be wrong a lot. Beta has to do with power. You know, again, if you have a very small sample, you don't have a lot of power. So a type 1 error means that you reject the null hypothesis when in fact the null hypothesis is correct. Remember, the null hypothesis says there are no differences between groups. Maybe there's no differences between students at Northridge and students at UCLA. That's what the null says. There's no differences. And maybe in the real world there really are no differences. Maybe like in terms of how much they study each week. But you reject the null and say there are differences. Now, if you made a mistake, it's because you set your alpha level to, you increased your chances of making your error too high, meaning you set your alpha level, let's say at 0.2, that means you have a 20% chance of being wrong. You really don't want that in science. It's too much. Okay, we like it usually around 5%, 10%, or 1%. That's usually where we're at. So remember, the type 1 error means that the null hypothesis was correct, but you rejected it. The type 2 error means the null hypothesis was wrong, but you failed to reject it. So maybe, like for instance, students at Northridge do study more on average than students at UCLA, but you said they don't. And in the real world, students at Northridge really do study more. That's a type 2 error. That means you should have rejected the null when you didn't. Those are the 2 types of errors you can make. Remember, your goal is to always be right. So if the null hypothesis is correct, you don't want to reject the null. You want to accept it, or at least fail to reject it. If the type 2, look, if there are differences, you want to say there are differences. Okay, so you always want to be correct. If there are differences between groups, you want to reject the null hypothesis and say that there are differences. So remember, the goal at the bottom is to always minimize error. Okay, the smaller the error is, the more confidence you're going to have, and the more likely you're going to make the right decision.